How can I use a picture graph to tell how many more kids prefer the swings than the slide? In this lesson, you will learn to solve compare problems by using information from a picture graph. A common misunderstanding: forgetting that comparing is finding the difference. We can add or subtract to find the difference. For example, 7 minus 5 equals 2, or I can think of it like 5 plus what number equals 7. If I start at 5 and count up to 7, 5, 6, 7, I still get the answer of 2. So let's review. In front of you is a picture graph. I know that some of the key things I need to look for when looking at a picture graph is the title, the categories, and the key. So I see my title is Favorite Playground Equipment. I see the categories are seesaw, slide, swing, monkey bars. And next I need to look for the key. I notice that the key shows that one smiley face equals 1. So it looks like students voted on their favorite playground equipment, and for each smiley face that represents one student's vote. So let's start by looking at the seesaw category. How many students voted for seesaw? If you said 3, you're correct. Now let's compare the slide and the swing. How many more students voted for the swing than the slide? Well, 6 students voted for the swing and 2 students voted for the slide, so I can look at it like 6 minus 2 equals 4, or I could also look at it like how many do I need to get? 2 plus what number will equal 6. If I start at 2 and count up to 6, 2, 3, 4, 5, 6, I still get the difference of 4. 4 more prefer the swing than the slide. 6 minus 2 equals 4, or 2 plus what number equals 6. It doesn't matter how I solved it, I still get the correct answer either way. Now what if I ask the question, how many more students needed to vote for the seesaw to have the same number of votes of monkey bars? So I'm looking at my picture graph and I see that there's 1, 2, 3 votes each for the seesaw and the monkey bars, but there's one more vote for the monkey bars. So one more student needs to vote for seesaw to equal the monkey bar votes. 4 minus 3 equals 1, or I could use addition and say 3 plus what number equals 4. 3 plus 1 equals 4. Let's take a look at this picture graph. The first thing you need to do is look at the title, the categories, and of course the key. Sports our class plays. The categories are football, basketball, soccer, and the key shows that one of the shirts represents one student. Now obviously the images here on the football aren't coming out exactly, but I know that each one of those represents a shirt. So how many people voted for football? 1, 2, 3, 4, 5, 6, 7. What about basketball? Go ahead and count. 1, 2, 3, 4, 5. And finally, our last sport is soccer. 1, 2, 3, 4. Oh, that's better. Alright, so now we can ask some questions about our graph. We can use our graph and compare data. So here's a question. How many fewer kids play soccer than football? Take a moment and try to solve it on your own. Well, in both categories, we have 1, 2, 3, 4 both playing football and soccer. But here's where it changes. There's more students playing football than soccer. How many more? 1, 2, 3. So there are 3 fewer kids playing soccer than football. I could solve it saying 7, the total number playing football, minus 4, the total number playing soccer, equals 3. Or I could have said 4 plus what number equals 3. Notice how both of these have 4. It stops there. And if I count it on, 4, 5, 6, 7, here are 3 to get my total number of football players. So 4 plus what number equals 7? The answer is still 3. Let's take a look at football and basketball. How many more kids would have to play football than basketball to be the same total? Or I could say, how many fewer kids play basketball than football? Looking at these two categories, I see that 2 more kids will need to play basketball to equal the football players. 5 plus what number equals 7? 5 plus 2 equals 7. Or I could have used subtraction to say 7 minus 5 equals 2. In this lesson, you have learned to solve compare problems by using information from a picture graph.